Nobody? Not one? That's the hardest thing we've done all year. Javon. 13, okay. Nothing from before 13? Does anyone have any questions from the homework that I assigned last night? So far, I am at 13. Manjo? 7? Anything before 7? No? Yeah? Okay. So, 7. Evaluate each without using a calculator. That's what we did all through our notes. So, 8 to the 0. What's anything to the 0 power? 1. 8 to the 1/3 is the cubed root of 8. What is the cubed root of 8? 2. If you don't know that, you don't have it memorized, you break it down. 2 and 4, 2 and 2. There's the cubed root of 8. 8 to the 2/3 is the cubed root of 8 squared. So it's 2 squared, which is 4. That's all it is. It's exactly what we did in our notes. 3 over 3 is 1. 8 to the 1 is 1. Or it is 8. 4/3, 2 to the 4th is 16. 5/3, 2 to the 5th is 32. Yeah? All right. Nothing till number 13 then? 11 you said. Right. You actually said that already. Okay. What little number should be right there? 2. So that is 3.8 to the 3/2. Because the little number becomes the denominator, the power becomes the numerator. So this one is negative 1.5 to the 2/3. Okay? That's always the same. If it's a fraction, that is 5/4 to the 3/2. Everybody good? All right. And number 13. Write an equivalent form for each number using a power with the exponent of 1/2. Jocelyn? Pardon me? Oh, 12D. Certainly. 12D. 0.36 to the 1.5 is the same as 0.36 to the 3/2 is the same as 36 over 100 to the 3/2. The denominator becomes the root. 36 over 100 becomes the radicand, and that is all cubed. The square root of 36 is 6. The square root of 100 is 10. Cubed, 6 times 6 times 6 is 216. 10 times 10 times 10 is 1,000, which is 0.216. And all of that is stuff you should be able to do without a calculator. Okay, back to 13. I want to write the number 2 with an exponent of 1/2. Well, anything with an exponent of 1/2 is the exact same as the square root of that, yes? So what square root of what would get me 2? So the square root of 4 gets me 2, so it must be 4 to the 1/2. What square root of what gets me 4? So that must be the square root of 16, which would be 16 to the 1/2. 10? So that's the square root of 100. 3? Square root of 9? 25. Anything else? Now, obviously, now that you can do 13, you can do 14. Because it's not going to be squared, they're going to be cubed, right? Everyone is good? All right. Please, excuse me, turn to page 42. Now, This is the only unit I will do this for. All right, the next thing in your book is your assignment for this unit. You will do that assignment without help from me. You can work with each other. You can use your notes. You can use the interwebs. I don't care. What I am doing this time that I will not do in the next 7 units is a couple of pages of notes like this. This is technically review for this whole unit. This could be your assignment. But I want you to see what I mean before I give you the thing that is actually marks. Everybody understand? So we will do these 2 pages as notes. Then I will shut up and you will start working on your review. Now listen to me carefully. It is your review, which means you should ask as many questions as possible now while we're doing this practice for your review. Because when we get to the review, you're expected to be able to do that yourself. Understand? Now, if you were in a cooperative situation where you are working with people and you are honestly all working, which I have seen happen twice in my 22 years of teaching experience. What always happens is one kid does it all and the other kids in the group copy from them. That's fine. I do not care. But remember 2 things. 1, your assignments are only worth 20% of your grade. So if you copy them all, the best you're getting is 20%. And 2, if you don't actually do the work and you fail the tests, that's 60% of your grade. So you should really attempt doing poorly, but doing them yourselves is very useful. And then there's the 3rd warning. Nothing is more of a red flag to us teachers than 100% on every single assignment and quiz, and then 20% on the tests. Okay? So, be honest, because the only relationship we have is based on trust and integrity, and if you choose not to follow them, well then, that's not a very good decision on your part, is it? So let us go on. Now, you will notice I've specifically said do these without a calculator. Most of you, as soon as you see those words, you quiver in your boots a little bit, but you don't need to because, of course, you know how to do all of this without a calculator. Actually, there is one question in this whole thing that you would need a calculator for, but the number is so big that your calculator won't show it anyway, and even if it did show it, you wouldn't be able to read it, right? Because we don't do the way what your calculator will show you in math class anymore. But we'll worry about that when we get to it. Everybody cool? All right. Now, all of you should be looking at that, and you should be going, yikes. But you shouldn't be going, yikes. Because what do you notice about that and that? They're the same base. So if they were x and x, what would we do with those exponents? Add them. So what are we going to do here? Add them. What is 5 plus negative 3? 2. So I have 0.3 squared. Now, since I'm not letting you use a calculator, a bunch of you will tell me that that equals 0.9. Does it? Of course not. What is it really? 0.09. Mr. Myers, I can't remember that. The decimals, how to multiply, barf. Fortunately, you can remember that Mr. Myers always says, don't use decimals. That is, of course, 3 over 10 squared, which is 9 over 100, which is 0.09. Yeah? Yeah. Now you will look at the next one, and again you will go, yikes! Should you? Of course I can scroll back over. Should you be scared of that second one? Why not? Because they're the same base, aren't they? If those were x's, you could do this in your sleep. So apply your knowledge. What do you do there? So I'm not even going to write this out. I'm so lazy. I'm just going to write x to the negative 8. What am I going to write here? X again, and what am I going to do there? Positive 6. What do I do with them? Add them to get x to the negative 2, yes? What does a negative exponent do to its base? That's how we write it. What is actually happening? This is x over 1, isn't it? So what does that negative exponent do to the base? You flip it over. Now there's a proper math word for it, which is reciprocate. Well, we know that that negative exponent is going to reciprocate our base, don't we? What's our base? It's not x. What is it? Negative 3 over 2. How does that reciprocate? It becomes negative 2 over 3, and that becomes a positive exponent. What is negative 2 over 3 squared? If you were using decimals, which are horrible, and I hate them. That's better, but 4/9 is what I would use. Because 2 squared is 4, and 3 squared is 9. Yeah? Yeah. Now, if on a test you said 2.25 and showed me no work, how much credit would I give you? I would give you none. Why? It's not showing me that you know any math. It's showing me you know how to punch buttons on a calculator. Right? Is this Foundations and Pre-Calculus Mathematics 10? Or is it, I know how to use my calculator 10? Right. So you should show me what? Your work. Some math. Right? All right. Barf! But again, nothing to worry about. What do? You can do this in your head. What's the numerator now? 1.4 to the 7th. And the denominator is 1.4 to the negative 2. What happens to that? Why? So it's 1.4 to the 9th. Now, we're in an interesting position here, yes? Because I did say evaluate, didn't I? Right? So technically, I said evaluate without a calculator. Do I really want you to go 1.4 times 1.4 times 1.4 times 1.9 times? Do you think I want that? No. Of course not. So in this case, and use your brain, if it's not something that makes any sense to even attempt without a calculator, then just leave it as simple as you can get it. Does everybody understand what I'm saying? If it came out to 2 squared, is that what I want? What do I want there? 4. Everybody with me? Barf! What's the new denominator? This is tricky. Whoa. 49? 7, because the bases don't multiply when they're the same. The 5 over 3? The 6 over 3. Now, some of you will want to make that 2, won't you? Be honest. Be honest. Some of you want to reduce that to 2. Is that a good idea? No, because you have to do something with both those exponents right now. What is it? Subtract. And to subtract, you need a common denominator, don't you? Do I have a common denominator? So let's do so. What is 2/3 take away 6/3? Negative 4/3. Now, if you got to there, you're halfway done. I would give you 2 out of 4. How can we make it 3 out of 4? Sure.
Does it just turn into 7 to the 7?
Nope. You reciprocate it because negative exponents cannot exist. So it becomes 1 over 7 to the positive 4/3. That gets you 3 out of 4. How could you get the 4 out of 4? How could you show me a little bit more math? You answer it. What do you mean you answer it? We've already got exponents.
Why did you have to put the the 1 over the 7.
Because, as always, a negative exponent reciprocates the base.
Oh, I keep forgetting that the 4 over 3 is the whole exponent.
Okay. What is the one last math thing you could do here? We spent all yesterday doing it. Page. Right. It would be 1 over the cubed root of 7 to the 4th power. Now, could you do even one more thing with this that would make me literally turn a cartwheel? Not figuratively. I would get up right here and do a cartwheel if a kid did the last step here without me telling them to. You cannot solve this. There is no equal sign. There is no solving. So what more could you do with that would literally make me do a cartwheel? 30 brains. Somebody's got it. You need that one. What do you mean by factor it? What does Gavin mean by factor it? Because he leaned over. Did you whisper factor it to him? All right, I'll allow it. What do you mean by factor it? Well, you simplify it, yes? How many 7s are under the radical sign there? How many groups of 3 can I get out? 1. So it's 1 over 7 cube root 7, because you left 1 7 under there. If you got to there, I would go nuts. Well, I wouldn't. I'd just do a cartwheel. There's actually another step you have to do there, but you won't see that until grade 11. Not square root 7. You wouldn't cube 7. You would multiply by the cube root of 7 squared. And then you would simplify that. But we aren't going to do that because that'll just confuse the issue. This shows me you know something. This shows me you know something more. This shows me you know a crap ton. This! Oh, I'd need to bring another tie because this would be soaked with tears of joy. Okay? I'm already getting misty thinking about it. For anyone who cares, I've never had a kid actually do that on their own. Ever. In the 10th grade. Not once. Ever. When? Never. Sometimes I have as many as 6 grade 10 classes a year, and I've been teaching in big schools for 11 years. You can do the math. You can guess how many students have gone through and how many students I've showed that to and how many have actually learned it. Maybe you guys will be the first.
Do you do that speech every time or just you?
No.
Okay, well then probably.
5.
X to the 5 over y to the 2 for y squared.
Absolutely correct, because of course this gets me y to the negative 2. And where does that have to go? To the denominator. Yeah? Because when I do y, what I have here, Paige, is x cubed times x squared, yes? For these two, agreed? Then I have y squared times y to the negative 4, agreed? Okay, well, this is x, and this is x to get x to the 5th, right? This is y, because y squared is y. That means nothing, right? You cannot multiply y by itself negative 4 times. So that has to be put down in the denominator, right? And now those two y's will cancel. Goodbye! And those two y's will cancel. Goodbye! And we don't write y, we write y squared. And then number 6. Now number 6, for some strange reason, the addition of the 10 and the 5 messes with you kids. If I gave you this, 10 over 5, what's the answer? So why does this mess with you when I put it in an exponent? But it does, because I've marked again, 6 classes a year times 11 years. This question screws everybody up. Split them up. The numbers go with the numbers. The letters go with the letters. So what is 10 divided by 5? 5 and 3. What's canceling where? Those are canceling. Those are canceling. Leave me with a squared. Where's this going? To the top. I already had 3 up there. I got 2 more, so it's b to the 5th. I don't know why people don't get it, but they don't. I just gave a question almost exactly like that on my grade 11 exponent test, and a bunch of kids got it wrong. But the -2 page means it has to move up. And there were already 3 of them up there, and now there's 2 more. Okay? Now, ladies and gentlemen, to be fair, I did mess with my grade 11s, and I made one of these negative. Does that change anything? No, because negative bases are allowed. So it would be -2. But a bunch of kids in my grade 11 class took that -2, and what'd they do with it? Moved it down here. Like crazy people. Are bases allowed to be negative? Yes. Are exponents allowed to be negative?
No.
Ever? No. What if they're negative in the denominator? They bring up. What if they're negative in the numerator? They go down. What if there's one with negatives in the numerator and negatives in the denominator? They switch. Look at you guys. Maybe I'm going to need a new tie to dry my tears of joy today before the test. Dun, dun, dun. What are we doing with number 7?
Multiplying the 3 and the 5 exponent.
To get what?
Negative or positive 15.
I couldn't fool you. 1.5 to the 15th over 1.5 to the 10th, or the 5th. What do I do now? Subtract. You could say subtract, but again, that messes people up because then negative, I like to cancel. Those 5 are gone. 5 of those are gone. And I got 1.5 to the 10th. Is that one I would expect you to evaluate if I didn't allow you to use a calculator? No. I do not want you doing 1.5 times 1.5 times 1.5 times 1.5. It would take forever. Cool? 2 ways you could do number 8. What are your 2 options? And I wouldn't mind hearing from someone other than Abby and Gervier, because there are 28 other brains in this room. That's not to put down Abby and Gervier, because you know as well as I do that if I don't let you talk, nobody's saying a word. But I would like to give somebody else a shot. So let's give them a chance to have nobody talk. And the silence was almost deafening. Not one of the 28... Oh, Edward, go! Yeah, because that means this whole thing is cube rooted, doesn't it? That's badass. What's the cube root of 8? 2. How many groups of 3 can I get out of A? 1. How many groups of 3 can I get out of 6? B squared. Did I leave anything under the radical? No. Done like dinner. Nice work, Edward. Well done. Why does number 9 scare you silly? There's negative exponents and fractions. But aren't those fractions already common denominated? So it's really pretty easy, isn't it? What do I do with 4 and 2? Somebody should answer that isn't Gervier and Abby, because the 4 and 2 is the easy one. And if you answer it, you've spoken, and then I'll be like, nice work. Keegan. You divide 4 by 2. Yeah, you do. And without your calculator, Keegan, what is 4 divided by 2? It is a tough question because when I ask that, if I wasn't making this big a deal out of it, I would hear 4 divided by 2. I would hear 4 clicks of a calculator because I would hear people doing that. I know this because I've asked grade 11s what 11 times 0 is and heard silence. Yes. So, Keegan. 2. Yeah, all right. Who would like to deal with the A's? Oh, yeah, now dead silence. Nino?
All right, so you were supposed to get the A negative 2 on the bottom, on the top, sorry, to the bottom, right? That makes A 4 on the bottom.
You're damn skippy, it makes A4 on the bottom.
Okay.
Nice. Now, what do we do with B? Abby?
You keep the denominator the same and divide it 2 by 1. By his turn.
You're here. You subtract. What is, and again, I've heard silence when I've asked this question. What is 2/3 minus 1/3? 1/3. I have heard that also been greeted with silence in grade 11 math classes in this building. So I have B to the 1/3. Is that 1/3 positive? So can it live up here? Is that a possible correct answer?
Yeah.
If you do that and leave it that way, am I happy? I'm happy.
But you're not ecstatic.
Can you make me ecstatic? What could you do to show me some more math there? Edward. 2 cube root B. Well, we don't write power 1, but yeah. Keep going. A to the 4th. Yeah? Now, ladies and gentlemen, these are 2 different things going here, yes? This one we would call exponential form because we left everything with exponents and we just dealt with the exponent laws, yes? Exponential. Just chilling, Mr. DeVries?
Just wanted to see a master at work.
Whatever.
No, I'm telling you the truth.
And this one we call radical form. Now, as you go forward into math and it gets more and more complicated, usually someone will tell you what form they seek. Or the question will tell you from what is being asked what form you should go with. Does everybody understand? You need to know both. If the question doesn't specifically tell you, and Mr. DeVries does teach higher up than I do, if you didn't tell them, you'd be happy with both of those, yes? There we go.
Aces.
Everybody cool? Yeah? Okay. So you try 10, because 10 is a giant mess. But it isn't really. Remember, 10 looks scary, but it also looks a lot like 9. So start with something you know, because every time you do something you know in math, if you do it right, it's going to end up making it simpler. If you get stuck, at least you've done something. No answer in my war of words over my projector. I fired a volley back at them, though.
You understand they're just going to try to delay.
That's what I want. Because then I'll just buy the lamp and do it, and then it's fine, don't worry about it.
Yeah, exactly. I fixed the power.
Yes. I actually bought a power supply, opened up the... How'd you get up there? Well, I used a Westcan ladder.
Scissor crane.
I brought the scissor lift up from the shop on the elevator.
I wasn't being serious. The only reason I came in was just because To remind myself.
All right. Now, we have a couple of options here, yes? We all know, if we've been paying attention, we all know what Edward would do, don't we? Because what did Edward suggest we do with number 4? I lie, number 8. He suggested we put everything under a cube root, right? Could we do that here? But it wouldn't be a cube root, right? We would go square root of 100a over 25a5b to the negative 1/2, right? Is that cool? Can we do that? Yeah. Okay. Now, does this square root cover everything?
Yeah.
It does, doesn't it? So, does it cover the square root of 100? Which is what? 10. Does it cover the square root of 25? Which is 5. Does it cover the square root of a? It does, but there isn't a square root of a, is there? But isn't a up there and a to the 5th down there? Isn't that a going to disappear and I'm going to have 4 a's there? So does the square root cover the square root of a to the 4th? Which is a squared, isn't it? And that would be in the denominator. And what bothers us here? It should move up here, shouldn't it? So it's b to the 1/2. But it's been square rooted, hasn't it? Right? Paige? You would think it would be, right? Because you would think, oh, I'll square it. But the square root is actually to the 1/2, isn't it? So it would be b to what power? No. What's 1/2 times 1/2? 1/4. B to the 1/4. That is harder than everything that will be on your test. Let's pretend you couldn't do it by yourself, but let's pretend you followed everything I just said. Are you ready to write your test? Because that is harder than anything you're going to see on it. If you could follow that, you're ready for your test. Now, can we do one more thing here? Which is this? Is this exponential or radical form? Exponential. So can we change it to radical just for the sake of changing it to show off? What would it be? What would it be?
A to the... I mean 10 to the...
2. 10 divided by 5. 2. 4th root b over a squared. If you could get to there, you're actually ahead of where most of my pre-calc 11s are. And they had this whole course, plus they've had a reintroduction of exponents with a couple of new things this year, and they still would have a little bit of trouble with that. That's how hard that question is. Am I doing it to scare you? Who said yes? Am I doing it to scare you, or am I doing it to show you that you should have some confidence here? There is not one of you that is totally lost on that. You're liars. Every single one of you could have done some of that. Now, could we have done it a different way? Because the square root thing kind of is a mess, isn't it? Right? Could we also have just done our exponent laws? Could I have brought this 1/2 into everything? So I would have had 100 to the 1/2, which we know is square root of 100, which is 10, right? And it would have had 25 to the 1/2, which we know is square root of 25, which is 5, right? And I know a and a to the 5th, oh, that's kind of a mess, but when I simplify it, it's a to the 4th, and that is an easy 1/2, right? Because 1/2 times 4 is 2. Everybody with me? All right. Okay, I need you to be honest right now. You've faced questions like this in the past, haven't you? And 99 students out of 100, as soon as they see x equals negative 2, they jump to the question and they start writing. Okay, negative 2 to the 3 halves, and then y is 3 squared. Oh, and then that's times negative 2 to the 1 half, and 3 to the negative. And they do that. They start substituting right away. How many of you have been guilty of that in the past? Be honest. Every single one of you. At some point. What is the verb that I stress every single day, every single question? It starts with an S. It ends with a Y. It has implif in the middle of it. Simplify. Why would you make 4 substitutions when you can simplify? Because what's going to happen when you do x to the 3 halves and x to the 1 half? They have the same base and the same denominator. So isn't that x to the 4 halves? And isn't 4 halves x squared? And what are you going to do when you do y squared and y to the negative 1? You're going to get y to the 2 minus 1, which is y to the 1. Do we write y to the 1? No, we don't. Now all of a sudden I have x squared y. And now we can do it in our heads, can't we? Paige, hit me. Why do you think that? We add the exponents when we're multiplying because of x squared times x cubed is xx, xxx, x to the 5th. What is x? What's negative 2 squared? 4. What is y? What's 4 times 3? 12.
Wait, can you say that one more time? That last part that I zoned out. Like what you just
Negative 2 is x. So that is negative 2 squared, which is 4. 3 is y. 4 times 3 is 12. Now, I'm going to be a real meanie. Number 12, your calculator wouldn't be able to evaluate it for you because the number is going to be weird. I want everybody to try that. Look at how freaky deaky it looks. Work with your friends. See if you can figure it out. It's extraordinarily badass. Number 12. Go. I'm going to have a sip of my water because I need to hydrate before I attempt this question. Keegan. It will equal negative 2, yes. Yo.
So the thing that we had yesterday for marks, do I like show that to you or?
What?
Or not yesterday.
What thing are you thinking of?
You said we had a page that was worth marks.
We had some quizzes. I don't recall doing a page that we did for marks.
Okay, well you said it was, but I did it. Also, can I go to the bathroom?
Yeah, sure. All right, who thinks they have it? What do you think it is? You got negative x to the 48th. Do I have anything else? Edward? Negative x to 144. Anything else? Javon?
X to the power of 44.
X to the 48th. Paige? 48. Pardon me? 48th? 40th. Negative x to the 40th. Negative x to... Ooh, that's interesting.
Yeah, I thought so too.
Anybody else? The right answer is on the screen. What? Simon, what do you have? You have x to the 48? Okay. I've already written that one down. All right. I'm telling you the right answer is on the screen. Everybody make a choice. Everybody has the one they think is right? Yeah? Okay. Wrong. No. Wrong. Wrong. That one. Now. Okay. Now, you will notice we had 19. I'm going to guess that was because Abby did some adding when she should have been multiplying. We had a 40, which means you did some multiplying, but not quite. And then we had a 144, which somebody was probably doing some squaring instead of just multiplying. So let's break this down. Now, let's say you had no idea, you left it totally blank, and we're just waiting so we could shoot the breeze about it. If you're one of those people, where could you start right now? Where would be a good idea to start, Paige? You could do that right there, couldn't you? And you would get x to the 4th, negative x cubed, to the 12th, which is pretty good, except if you do that, you make a small error. Because that 3 also needs to apply there. Because it's in big brackets. Okay? So you would actually have x to the 12th there. Everybody cool with that? When you see that, right? Everybody good? Now what could you do? You could do this right here, couldn't you? Right? Which would give you x to the 12th and then negative x to what power? To the 36th, right? Now, what do we know about a negative base and an even exponent? The base becomes even? The base becomes positive, yes? So I would have x to the 12th and x to the 36th. Agreed? And now what do we do? Add them to get x to the 48th. Now this is where we're good, right? Now what's x equal? No. Negative 2 to the 48th, which is the same as... Yeah, but negative base,
48 to the negative 1.
positive 2 to the 48th.
This is getting
Now, listen up. Again, million times harder than anything I would put on your test. Right? But think about what you tried. Even if you didn't have the guts to say your answer out, the only mistake I heard, like when I reminded you that this 3 went to the 4, I heard a lot of people go, oh. If that was your only mistake and you showed me everything else, how much math do you know? Quite a bit, right? It's nothing to be down about if you made that one little error. Yeah? Now, if you left it totally blank, you had no idea how to start, we're getting a little late for that. Right? And if you left the negative in there, I mean, technically you're right? But our goal in math is always to have it as simple as possible, yeah? 6 over 4 is a right answer, but 3 over 2 is better. So that negative, while it's right, it's got one too many symbols than we need. Picking up what I'm putting down? Everybody good? You ready to try go on your own onto the... oh, I lied. 2 more things. Now, this is weird because you don't know these formulas. So, now you're intelligent young people. Our next unit is polynomials, yes? Which means we're going to be dealing with variables and algebra. So the very last thing I want to do in this unit is do some algebra. If you don't remember how to do the algebra, is it a big deal? No, but I need to know the clay that I am working with, yes? So I'm going to give you the formula for the volume of a sphere. I want you to tell me the radius of the sphere, which in the formula is the letter R. Everybody cool? So volume equals 4 pi r cubed divided by 3. How many unknowns are in that right there? How many unknown values are there? Only 1, because we know the volume is what? 425. So this becomes 425 equals 4 pi r cubed over 3. And I want r by itself. See if you can do it. You can work with neighbors. You don't have to try it yourself. I want to see what I get when I ask you to just do some algebra. Because the very next unit has algebra in it. And if you don't remember, again, it's no big deal. I'll just review algebra next unit. But the less review I need to do, the more time I have to work on the new stuff. I went and saw 1917 last night. This was cheap night. Technically a tour de force, an amazingly shot movie. Story-wise, a little lame. And historically accurate, not even a little. 1917.
What happened in 1917?
The World War I.
I totally knew that.
Like 40 million people killed. Europe turned to rubble.
I definitely knew that.
Okay. In Flanders fields, the poppies grow between the crosses row on row. Oh, wait. It's blow in the first stanza. It's grow in the second.
I don't remember.
I think what's really amazing about this movie is the fact that the runner lasted so long, since so often they would die so quickly.
The witch?
Like, the main character,
Oh.
the messenger, like, they died, like, super quick usually. So it's just, I think that's one historical fact about it. Most of the time it would just be a messenger with another.
People got home. All right. Are we ready to attack? Are those cheesies, Carlo? Are they Hawkins cheesies, or are they some knockoff like Cheetos? Oh, they're my second favorite kind of cheesy chip. My favorite being the Canadian Hawkins cheesy, the only thing actually called a cheesy. If you don't know what I mean, they're in those little bags with the red and white stripes. Yes, they are so good, and they are a Canadian invention.
I haven't eaten so many.
All right. What should we do first? Nobody remembers algebra?
Well, isn't the radius?
Wow. Okay. Paige.
I got 141, 6 repeated 7.
That might be right. That might very well be right. What should we do first?
Cancel before.
You don't cancel.
Divide R3 by 3 and then
multiply our 3 by 3. Right? We want to do multiply by 3.
What? I divided R3 by 3 and then divided 425 by 3.
That won't help you. But you're on the right track. You had to do something with the 3. What's our goal? We want r by itself, yes? Well, divided by 3 is in the way of r being by itself, yes? How do you get rid of stuff in math? You do the opposite. Well, divided by 3 is in the way of r being by itself, right? So we're going to multiply by 3. What's going to happen to that red 3 and that blue 3? They're gone. So now I have 4 pi r cubed equals. Now, if I multiply the right side by 3, what do I got to do to this side? I got to multiply by 3 or it won't be equal anymore. That is 1275, right? Okay, now what's in the way of r being by itself? What math is happening there and there? You do know what math is happening when we write two things in math right beside each other. Multiply. So how do I get rid of times 4? Divide by 4. How do I get rid of times pi? Divide by pi. If I divide this side by 4 pi, what do I got to do to this side? Divide it by 4 pi. Now, what happens to that 4 pi and that 4 pi? They're gone. Now, r is almost by itself. What gets rid of a cubed?
Where did the 1275 come from?
That's 3 times 425. How do I get rid of a cubed? What's the opposite of cube? Not square root. Cube root. If I cube root, that's going to get r by itself, and this side would be cube rooted. And now you could go to your calculator if you wanted to. And Paige, you're very close to being right, except you probably just punched something into your calculator wrong, because it should be around 1275 divided by 12, 100, cube root of 100. It should be around 6-ish. But there will definitely be a decimal.
So the answer is
Cube root 1275 over 4 pi. That would be the best answer you could give me, because then you don't have to mess around with your calculator. All right? You're going to try one more piece of algebra, and then I'm shutting up. Yeah.
by ourselves?
Well, we'll see. Volume of a cone equals pi r squared divided by 3. Oh, sorry, pi r squared h divided by 3. Now, what there do I know?
That you have to get.
I see 3 letters. Those letters are usually unknown. What is known there? Page. I know volume is 18. Pi. What do I know about r and h? Read the question. What do I know about r and h? They're the same numbers. So do I need 2 different letters? So what can I write here instead of h? R. I got r squared and r. So what is that? R cubed over 3. Now all you should be able to solve that. And tell me what r is. You got to get r by itself. You don't need to cube 18. You need to find a... That would be 54. If you were needing to multiply 18 by 3 for some reason, you would be looking for 54. Do you need to multiply 18 by 3?
I think so.
Well, then you should probably continue with that and see what happens. Because the worst thing that can happen is I say, sorry, Abby, that's not right. What should I get rid of? Abso-smurfly correct. What happens to those 3's? They're gone. So now I got 54 equals pi r cubed. Now what? I would divide by pi. And what's going to happen to those pi's? I ate them. Now what? How do you get rid of the r cubed? You do a cubed root. Now, if you get to there, you've done all the algebra really you could do. And I'm super happy. But of course you know that is that cube root covering everything? So isn't that the cubed root of 54 over the cubed root of pi? And don't we know the cubed root of 54 is 27 times 2? And we know the cubed root of 27 is what? 3 cube root 2 over cubed root of pi. Now, in grade 10, would I be happy if you left it like that? If you took it that far, I'd be over the moon. What's going to happen in grade 11? You're going to need to know how to deal with that. But you don't have to worry about that till grade 11. To be perfectly honest, if you got to here in grade 10, I'm on my way to the moon. If you got to here in grade 10, I'm on the moon. Everybody understand? All right. Now listen. Your review is much closer in difficulty to your test than most of this was. Okay? So if you do well on your review, you'll be fine for your test. I have 1241, class ends in 20 minutes. Your review starts on page 48. It goes until page 53, I want to say. But I'm not 100% sure. It goes to 50. I'm the worst kind of liar. It goes to 51. That is due for marking Friday. Now, you're intelligent young people. It's the last thing in this unit, yes? Which means tomorrow we start our next unit, yeah? Friday we mark this. We continue on with our next unit. Once we have marked the review, I can give a test at any time. Are we clear? If we're marking the review Friday, I reserve the right to give you a test on any day after Friday. I am not saying what day it will be because I am tired of people getting incredibly ill for exactly one block on my test days. Clear? Okay? Okay. Go. You can move around, you can work together. But remember,